Welcome to first PU online classes. Dear students, continuation of the circular motion. Now, yesterday we had discussed the motion of a car on the which road here, level road, but circular level road. That is, a circular is there, but level is there. That is called as a motion of a car in a circular level road. Now this is a circular level road we have discussed yesterday. Now today we are discussing the motion of a car. Motion of a car on a banked road. Banked road means yesterday we have discussed the motion of a car on the level road. Here what is here? Motion of a car on a banked road. Right. First of all, what is the banking of road? We will discuss here. Now first of all we will discuss the banking of a road. Suppose we are traveling on the road. When the curve is there, road is curve means it is in the circular curve is there, like this. Now in these cases, they are increasing the outer edge. Outer edge of the road is increasing above the inner edge. The outer edge of the road is increasing above the inner edge in the time of what is here, constructing the what is here roads. When in the time of the constructing the roads, what is here, outer edge of the road is increases than the what is here, inner edge of the road. That is called as a what is here, banking of a road. What is the definition of the banking of the road? This is the what is here, rising the, here what is here, this is the rising the, here this is a rising the what is there, outward edge of the road. Outward what is here, edge of the road, slightly, outward edge of the road, slightly above the inner edge of the road. Now what is there? This is making in constructing the what is there, roads. They are making here when the curved path is there. At the curved path, the outer edge is rising than the inner edge of the road. This is called as what is there, banking of road. Banking of means outer edge is increasing than the inner edge of the road. Means outer edge is above is there, inner edge is low is there. This is called as what is here, banking of a road. Now next we will discuss the banking angle. Right. Now this is a banking angle. This is called as a banking angle. Now this is the outer edge of the road is increasing than the inner edge of the road. The angle through which the banking angle means what is there? The angle through which the inner edge of the road. The angle through which the outer edge of the road is rising. The angle through which the what is here, outer edge of the road is rising. Outer edge of the road is rising is called banking angle. Means in between the inner edge and outer edge, here some angle is there. That angle is called as a banking angle. Here this is called as a banking angle. This is the what is here, the angle through which which edge is increasing, outer edge. In comparison to inner edge, outer edge is increasing with some angle. That angle is called as here, this angle is called as a banking angle. Right. Now next to here, this is called as a banking of the road. Banking of the road means this is a rising of the outer edge of the road slightly above the inner edge of the road. This is making what is there when constructing the roads. here what is here, they are making like this because of, in order to avoid the slipping of the vehicles on the road. In order to avoid the slipping of the vehicles on the road, they are making the, what is the banking of the roads. This is here, when banking is not there, they can easily slip out from the road. That's the reason they are making the, what is here, banking on the road here. This is a banking on the road definition is what is here. This is a rising the outer edge of the road slightly above the inner edge of the road. Means here comparison to the inner edge, they are rising the outer edges slightly. This is called as what is here, banking of road. Next, another one is called as a banking angle. Banking angle means how much angle we are rising the, what is the outer edge of the road, through which how much angle the outer edge of the road is raised, that angle is called as banking angle. Right, now we will discuss here motion of a car on a banked road. Now this is a banked road. Here the car is moving like this. It is coming in the front direction. You assume that this is coming in the front direction. Here this is moving on the, what is here, this is a curved road. Here curved road is there. Here angle theta is called as a banking angle. The car is coming like this. When car is coming like this, the friction force is acting in between the, what is here, road. This is the tires. This is assume that here this is the tires of the car. Here this is the, what is here, car here. This is the tires of the car. In between the tires of the car and the, what is here, circular road. Here what is acting here in this direction? Which force is acting here in this direction? Frictional force is acting. Here frictional force is acting in this direction. In between the, what is here, tires of the car and the, what is here, which road here? Circular road. This is a circular road is there. On the side, in between the circular road and the tires of the car, which force is acting here? Frictional force is acting. That is acting in this direction. Why it is acting in this direction means to avoid the slipping. To avoid the slipping means here it is moving like this, means suppose the car is moving like this, means here slipping like in this direction. In order to avoid this one, the frictional force is acting in this direction. So that's the reason the frictional force is acting in this direction to avoid the slipping of the car. Slipping of the car. Who is what is here? Who is helping here? What is here for the without slipping of the car means the frictional force is helping. That's the reason the frictional force is acting in this direction. Means here two situations are occurring in these cases, but only one situation is we are discussing here. The car is sliding upward. The sliding in the upward direction means it is sliding towards the here what is here upper edge. It is sliding towards the upper edge here. We are considered here. Here the both cases is there, but in the NCERT textbook only one case is given. When the car is sliding towards the upper edge, it is moving in this direction. It is sliding in this direction. When it is sliding in this direction, the frictional force is acting in the opposite direction. Actually, two cases is there. The car is sliding up or the car is sliding down. The car is sliding in this direction. Sliding means slipping. The car is slipping in this direction. The frictional force is acting in this direction. Why frictional force is acting in this direction means to avoid the, what is here, to avoid the slipping here. Here when the it is moving in this direction, the friction is not there, it will be slip on the road. But due to the friction, it is not slipping. The car is not slipping when car is coming in this direction. Listen here, the car is coming in this direction, the friction is acting in this direction. When the friction is not there, the car will be slipping in this direction. Simply. Here due to the friction, the car will not be slipped. Means the friction is acting in this direction. Right, this is why friction is acting in this direction. I explained here. The friction is acting in between the tires of the car and the road. It is acting in this direction because the car is slipping in this direction or car is rising in this direction. This is here what is here? Friction is acting in this direction, but actually car is moving in the forward direction. But here it is coming in this forward direction. Here slipping in this direction. When it is slipping in this direction, means friction is acting in this direction. Clearly understand here. Now this is the friction is acting in this direction. Now this is the friction. Here we know that here this is a car is there. This is a normal reaction. We know that already normal reaction. Suppose this is what is the inclined plane. Suppose I am placing the body like this. This normal reaction is acting perpendicular to the this plane. Means that's the reason this is a normal reaction is acting in this direction. Now this is a normal reaction is acting in this direction. Now this is angle, this is a theta is called as a angle of what is here banking. Angle of banking is there. This is called as a theta. When this angle is theta, here also becomes to be theta. From the here rules of the triangle, this is a what is that? This is a theta is there. This is also theta. Now this is a normal reaction. Normal reaction is divided into two components. I am showing here. This is a what is here normal reaction. Here it is in this direction will be there. Here angle is theta. Angle is theta. It is dividing into two components. This is a horizontal component n cos theta. Because angle here making here means this becomes to be horizontal. This is a vertical component n sin theta. You are already studied in the vectors here. Suppose here this is a bar is a vector. Here angle theta is there. This becomes to be a cos theta. This becomes to be a sin theta. Because this side is a bar is making an angle theta with this side. That's the reason this becomes to be horizontal. Suppose now this is a bar is there. Now here making angle theta. Here this becomes to be a cos theta. This becomes to be a sin theta. This is the horizontal. Right? This is horizontal means this a bar is vector is making an angle theta with this side. That's the reason this becomes to be horizontal. This becomes to be vertical. Clearly understand. Here. Now when depends upon the angle, what is here? The components can be changes here. This is the a bar is there. Here making an angle theta means this is a cos theta, a sin theta. Means the vector making an angle theta with which side or with which side it can make it can make the x-axis or y-axis like this. When it is making an angle theta with x-axis, the x-axis side component becomes to be a cos theta, y-axis side component becomes to be a sin theta. Suppose a bar is a vector, it makes an angle theta with the y-axis. Now y-axis side becomes to be a cos theta, x-axis side becomes to be a sin theta. This becomes to be vertical component, this becomes to be horizontal component. In this case, this becomes to be horizontal component, this becomes to be a vertical component. Depends upon the angle, it can be changes. Now, here also what is I am writing here? We are making the angle. This is n bar is making an angle theta with this side. Means this side is becomes to be, suppose this is I am taken as a y-axis, this is taken as a x-axis, means this becomes to be horizontal component n cos theta, this becomes to be vertical component n sin theta. So I am writing this is a n cos theta, another one is this is a n sin theta. This frictional force is also acting in this direction. This angle is theta means this angle also theta. Now this is a normal reaction is acting in this direction. This is dividing into two components. One is a n cos theta, another one is a n sin theta. Frictional force is acting in this direction. Here angle theta means this angle also theta, and here angle theta means this angle also theta. Now here n normal reaction is acting in this direction. Weight is always acting towards the center of the earth. Mg is acting in this downward direction. Right. This is totally clear explanation of this diagram. Again we are drawing this diagram here below. Same diagram I am drawing once again here. Now here this is already we know that here n is divided into two components, n cos theta, another one is the n sin theta. Here the weight is acting in the downward direction mg. Here this is the friction. This friction also makes an angle theta with horizontal. Here this is clear. Now I am showing that here this is the friction. Here this is the friction. Here this is the friction. It is makes an angle theta with horizontal. Now this is a makes an angle theta with horizontal. This is taken as a horizontal. Suppose this is the horizontal. Now it is also makes an angle theta with the horizontal. Now I am drawing here once again here. This is the friction. F. It makes an angle theta with horizontal. Now this is taken as a vertical. Means here it makes an angle theta with this side. This side means this side becomes to be f cos theta. This side becomes to be f sin theta. Here also friction is dividing into two components. One is becomes to be f cos theta, another one is becomes to be f sin theta. So this is I am written as a f cos theta. This is I am written as a f sin theta. This is n sin theta. Already is there in the same direction. It is coming here f cos theta. Here mg is there in the same direction. What is coming here f sin theta. Means this friction is dividing into two components. One is becomes to be f cos theta, another one is a f sin theta, because it is also making an angle theta with this horizontal. So this becomes to be f cos theta, this becomes to be f sin theta. That is totally I am showing in this diagram. Right. Now we are writing here. Suppose the car is in the what is here? The car is moving safely on the what is here curved road. Safely moving on the curved road means these forces are balanced. When these forces are balanced with each other, it can move what is here safely. Otherwise, it can slip out from the road. Here, that's the reason we are writing that it is moving safely on the road means here this is the total forces are balanced with each other. Now, what is I am writing here from this diagram? Here this is the first of all I am comparing this is the upward force compared with the downward forces. Now, observing the diagram. Here what is the upward force is what is here n cos theta. Downward force is f sin theta plus mg. F sin theta plus mg. This is given to the equation number 1. This is the upward forces are balanced by the downward forces and the car is moving safely on the road. Now this is what is n sin theta, f cos theta, both are acting in this direction. This n sin theta plus f cos theta both are acting in the same direction. Same direction means the total sum of these two forces gives a centripetal force. This is a centripetal force towards the here what is the center of the road. This is a curved road is there. This is the upper end. This is what is the lower end. Here towards the center of the road, what is the forces are acting here? N sin theta plus f cos theta. Here this is a curved road. Here this is a curved road means towards the center, centripetal force is provided. Who is provided the centripetal force? This n sin theta plus f cos theta is provided the which force here? Centripetal force. Here this is called as which forces are provided the centripetal force means n sin theta plus f cos theta. By adding means both are acting in the same direction. Here also I am adding f sin theta plus mg. By adding means both are in the same direction. Vectors both are having the what is here in the same direction means we can add directly. So here in the first case I am writing n cos theta. Upward forces are balanced by the total downward forces. So n cos theta is equal to f sin theta plus mg. First condition we have written. This n sin theta plus f cos theta is acting towards the center of the circle or center of the circular road. That's the reason this n sin theta plus f cos theta is gives a which force here? Centripetal force. So from this I am writing here this is a say that gives a centripetal force means that is I am writing here n sin theta plus f cos theta provided the centripetal force, that is I am writing here mv square by r. What is the r here? R is the radius of the road or radius of the circular road. This is r is called as, suppose this is a circular road is there. Here what is here? We are making like this total circle. Here we are making the total circle like this. Here this is gives what is here? Radius r. Right, this is called as a radius. What is that taken here? Small r. This is called as a radius r. R is called as a radius of the circular road. Right, these two equations are here written. This is going to be equation number 2. Once again I am saying that this is a n is divided into two components. One is called as a n cos theta, another one is a n sin theta. Because this angle is theta means this is also angle theta. Here theta is called as a what is here? Angle of banking. This n cos theta balanced by the f sin theta and mg, because f sin theta and mg both are acting in the same direction. Here f sin theta plus mg is balanced by n cos theta because upward forces are balanced by the total downward forces. Now similarly friction is dividing into two components. One is the f cos theta, another one is what is here? F sin theta. So n sin theta plus f cos theta, always this is acting towards the center of the circular road. This is n sin theta plus f cos theta is gives a which force here? Centripetal force. Right, this is we are giving the centripetal force. From this we are writing the two equations. Now here this is what is here? Rearranging these equations. N cos theta is equal to f sin theta plus mg. N sin theta plus f cos theta is equal to mv square by r. Now rearranging the equation 2. Now what is I am writing here? N sin theta is equal to simply r. I rearrange the equation 1 easily. Now from equation 1, what is I am writing here? N cos theta. This is taking here. This is plus is there. You are taking minus. F sin theta is equal to mg. This is given to equation number 3. Equation 3 I am writing here. Now this is I am writing the equation 3. Here from this I am writing here. This is given to equation number 3. Now equation, what is here? This is equation 2 is divided with equation 3. Simply, equation 2 is divided with equation 3. Now equation 2 is divided with equation 3. What is we are getting here? N sin theta plus f cos theta by, here what is here? N cos theta minus of f sin theta is equal to, this is mv square by r by mg. I am writing here mv square by r by mg. Equation 2 divided with equation 3. Now mn, what is here? Getting cancel. Now what is we are getting here? N sin theta plus f cos theta by n cos theta minus f sin theta is equal to, what we are getting here? This is v square by rg, because this is a g by 1 taken, means what is getting here? Simply v square by r. I am showing here v square by r into 1 by g, coming like this. Now I am showing here, this is v square by r into 1 by g, that value is equal to v square by r. Right. Now this is here n sin theta plus f cos theta by n cos theta minus f sin theta is equal to v square by rg we are getting here. Now for maximum safe velocity, when velocity becomes to be maximum and it becomes to be, what is that? That is called as a maximum safe velocity. That is I am taken as a, when velocity becomes to be maximum safe velocity, means here v is becomes to be v maximum, that friction is becomes to be, what is the friction is there? That friction is becomes to be limiting friction or maximum value of the static friction, that is f is equal to fl into mus. F is equal to fl is equal to mus into n. For this condition, that velocity becomes to be, what are the velocity is there? That is the velocity of the car which becomes to be, what is there? Maximum safe velocity. What is the condition for maximum safe velocity? V is equal to v maximum, and what is there? Friction is becomes to be limiting friction, that is equal to the mus into n. That condition we substitute in this equation. Now this is equation number 3 completed. We substitute in equation 4. Now when substituting equation 4, what we are getting here? Here this is called as a maximum safe velocity. For the maximum safe velocity, v is becomes to be v maximum. Friction is becomes to be, what is the limiting friction? That is mus into n. Now from this I am writing as a, here simply n sin theta plus f cos theta. In the place of the f I am writing here. This is a n sin theta plus f is equal to fl is equal to mus into n. F is equal to mus into n. What is I am writing here? Cos theta by, now I am writing as a n cos theta minus of f is equal to mus into n. What is we are getting here? Sin theta is equal to, here v becomes to, what is here? V maximum. So v maximum square by rg. Means in this equation I am substituting in the place of the v, in the place of the v I am writing as a v maximum, in the place of the f I am writing as a mus into n. Here mus is called as a coefficient of static friction, n is called as a normal reaction. Now in these two equations we can take the n, take the common. When n taking the common, remaining is sin theta plus mus cos theta, sin theta plus mus cos theta by cos theta minus of mus sin theta is equal to v maximum square by rg. I am writing as a v maximum square by rg. Here also, here n taking the common, here below also taking the n common. Here this is n, here taking the common, here also taking the n common. In the numerator and denominator I am taking the n common. Now what is here? N am getting cancelled. Now what is here getting here? Simply sin theta plus mus cos theta by cos theta minus mus sin theta is equal to v V maximum square by Rg I am writing. Now listen here carefully. Right, in this equation I am taken as a n common, that is becomes to be sin theta plus mu s cos theta in the numerator. In the denominator also taking the n common, cos theta minus mu s sin theta. Here this n is cancelled, remaining is sin theta plus mu s cos theta by cos theta minus mu s sin theta. This is remaining is there. Right. Next here, what is I am making here? In this equation I am taking the cos theta common. Cos theta common means remaining is what will be there here? Cos theta common means remaining is cos theta common means what is here? In the numerator and denominator I am taking the cos theta common, or another way, simple way I am saying that. Here numerator and denominator is divided with the cos theta. Here or simply I am writing here directly. Here numerator and denominator I am dividing with cos theta. Sin theta plus mu s cos theta by in the denominator cos theta minus mu s sin theta by cos theta. Right, numerator and denominator I am dividing with cos theta. When dividing with cos theta, there is no change in the value, because again cos theta cancel, we are getting same value. Here is equal to what we are getting here, V maximum square by Rg. V maximum square by Rg. Now what is here? This is divide separately, sin theta by cos theta, and directly I am writing here. Separately we can divide. Here what is there? Writing here, again one step I am writing here, sin theta by cos theta plus here mu s cos theta by cos theta, separately I am dividing by, now cos theta by cos theta minus of mu s sin theta by sin theta, mu s sin theta by sin theta is equal to V maximum square by Rg. Right, now I am removing this one diagram. Next I am writing here this is sin theta by cos theta is equal to, we know that, tan theta plus here simply here cos theta, this is also sin theta by cos theta. Sin theta by cos theta. Now what is there, tan theta? Here what will be there? Here cos theta cancel. Here also cos theta cancel. Remaining is tan theta plus mu s by 1 minus mu s tan theta. 1 minus mu s tan theta. Sin theta by cos theta is tan theta is equal to V maximum square by Rg. From this V maximum square by Rg is equal to tan theta plus mu s by tan theta plus mu s by 1 minus mu s tan theta. Now Rg take outside. Now V maximum square is equal to Rg into tan theta plus mu s by 1 minus mu s into tan theta. Right, from this we find the V maximum velocity and maximum safe velocity of the car. V maximum is equal to, we are getting here, this is under root of here Rg into tan theta plus mu s by 1 minus mu s into tan theta. This value we are getting here. Now this is the maximum safe velocity of the car. Or we can write like this also. That expression I am writing like this also. what we are getting here, that expression. Now I am writing that expression in this way also. Now V maximum is equal to Rg into, here what is here, Rg into tan theta plus mu s by 1 minus mu s tan theta. Here this whole power of 1 by 2. Why whole power of 1 by 2 means this will be in the under root is there, total value in the under root is there. Now next we are discussing one case here for frictionless surfaces. Frictionless surfaces means the coefficient of static friction is 0. But it is moving on the what is here, banking road, but banking road not having the friction. That is called as a frictionless surfaces. And the frictionless surfaces Q(s) is equal to 0. It is moving on the banking road, but it is not having the friction. When the coefficient of friction is not having, means coefficient of friction is 0. We substitute that equation. Here equation 4 already completed. This is going to equation number 5. Now this is equation 6. Now we can substitute in this equation also. From equation 5, substitute the Q(s) is equal to 0. What we are getting here, V maximum is equal to under root of gamma, here this is Rg, not gamma here, Rg into, here what is here, tan theta, mu s is equal to what is here, 0 by 1 minus mu s is equal to 0 into tan theta. We substitute just in the place of the mu s is equal to 0. Now what is we are getting? Here substituting the 0. Here this value tan theta was 0, tan theta. Here 0 into tan theta 0. Means the remaining value is V maximum is equal to under root of, here what is we are getting here, Rg into what is we are getting here, tan theta by 1 minus 0. This is 1 minus 0 we are getting here. This value is equal to tan theta. I am writing like this here. Rg into tan theta. Tan theta plus 0 is tan theta by 1 minus 0. By 0 means 0 into tan theta is equal to 0. Means V maximum is equal to under root of Rg tan theta. Yeah, tan theta by 1 is equal to tan theta. So V maximum is equal to, yeah, this is another way we are writing here, Rg into tan theta. What will be there here, whole power of 1 by 2. This is another way we are expressing this equation. This is when the friction is not there. This expression is when friction is present. This expression is when friction is not present. Not present means we are banking the road, but what is not there? Friction is there. Friction is not there. Banking the road is there, but friction is not there. In this case we are getting here V maximum is equal to Rg tan theta whole power of 1 by 2. In the yesterday case, what is we are discussed in the previous class, there is friction is there but no banking. Here in this last case what is there here, friction is not there but banking is there. Here clearly remember the conditions. In the last class banking is not there but friction is there. In this fifth equation, banking is present, friction is present. Here in this case means this is given to equation number 7. In the equation number 7, what will be there here? Banking is there, but what is not present here? Friction is not present. Right? Here clearly we can what is here differentiate the conditions because of when we use this formula. Which formula we can use? Depends upon the conditions. We can use that formulas. In the yesterday formula we can use when the friction is present, banking is not there. Friction present, banking present means we use this formula. Here banking present, friction is not present means we use this formula. Right? Okay, thank you.